Welcome to lesson 2 on C1 topic of chemistry. So what we're going to be covering today is today's atmosphere, and the thinking challenge is what were the two main gases in the Earth's early atmosphere? This is what we covered in lesson 1. So what do you think these are? And then a stretch activity, why did the levels of carbon dioxide in the Earth's atmosphere decrease to the current levels today? So the first one is the two main gases were carbon dioxide and water vapor. And for your stretch activity, the reasons why the carbon dioxide levels decreased is because of the carbon dioxide dissolving in the oceans to form carbonic acid. You have marine creatures which take these in the sea. These then die and fall to the bottom, and these form sediments. The layers then build upon each other, and these get locked into carbonate rocks. And then the third one is the evolution of plants, and through photosynthesis, this is where it takes in carbon dioxide and then it produces oxygen. Right, what we're going to look at is, in today's lesson, we're going to describe the composition of the atmosphere and explain why it is still changing. So, like you did in the last lesson, if you can just place where you are on the solo, and hopefully you can see progress. So, the three outcomes for today is describe the composition of the Earth's atmosphere. We're going to explain why the Earth's atmosphere is still changing and suggest how you could investigate the amount of oxygen in the atmosphere. So I have three gases there, A, B, and C. Gas A, which you should have guessed, is oxygen. Gas B is nitrogen. And gas C is other gases, including carbon dioxide. So what you can see from there is that the atmosphere, from the early atmosphere, has changed in composition. We now have 78%, which is nitrogen, 21% is oxygen, and you can see from that that carbon dioxide is now a relatively small gas at 0.037. Right, the atmosphere is still changing. One of the things that you need to be aware of is the human influence. So these are burning fossil fuels. If you burn these, it releases carbon dioxide. Examples of this will be power stations and cars. Deforestation means chopping down trees. So a lot of the big forests like the Amazon, these are where trees are chopped down. These take out carbon dioxide from the atmosphere using photosynthesis. So if we have fewer trees, this means that we have less carbon dioxide that's taken out. And another thing that changes is farming of animals. And because the population of the Earth is increasing, what you find is a bigger demand for meat. So farm animals such as cows, they produce a lot of methane when they pass wind. Okay, so that's one of the things that can change the current atmosphere. We also have natural influences, and an example of this in your exam could be to give the volcanoes. Volcanic activity changes the atmosphere in that it gives out sulfur dioxide. This can be thrown high up into the atmosphere when it erupts, and it also produces a lot of carbon dioxide. This is what's released. So, why do scientists not know exactly how the atmosphere changed? Well, a few things that you need to think about is scientists they've learned a lot by studying bubbles in trapped air, which has been nice. However, no one was around when the atmosphere was changing millions of years ago, so a lot of it is down to educated guesswork. Okay. So, quick learning check. You can pause the video now, have a quick go at these two questions, and then we'll go through the answers. So the first one is describe the composition of the Earth's atmosphere. You should have had that. It's 78% nitrogen, 21% oxygen, and carbon dioxide at 0.037. And you've also got other gases like argon. And explain why the atmosphere is still changing. The Earth's atmosphere is still changing by humans burning fossil fuels, which releases carbon dioxide, deforestation cutting down trees so less carbon dioxide is taken in, and farm animals producing methane. You could also mention volcanoes also release carbon dioxide and sulfur dioxide when they erupt. So, the final thing we're going to look at is suggest how we could investigate the amount of oxygen in the atmosphere. One thing that you can do is you can do this in the laboratory, in your science classroom. So you can find that the atmosphere, you should be able to find that the atmosphere contains 1/5 oxygen, which is about 20%. So if you heat copper, it reacts with oxygen to make copper oxide. So it uses up the oxygen. So you can do this in an experiment. So if you heat the copper in the tube and pass air over it using 2 syringes, as in the diagram, if you use markers to tell how much oxygen is used up, if you start with 100% of gas from the air and you end up with 80, then you know that you've used 20 centimeters cubed. So that shows you that you've used 20%, and that 20% proves to you that there's 20% of oxygen in the air. Another way to do this is from a past exam question, is to use a candle in a jar. So if you light a candle, put it in the jar with water over it, what you should find out is that when the flame goes out, the water rises. So the water level has risen because the burning candle uses up the oxygen, and the water takes the place of the oxygen. So if you mark the glass jar, you can then show that exact amount, or you can roughly guess that it does go up by 1/5, which it will go up 20% of the jar. Okay. Right, so the question that we looked at the beginning was describe the composition of the atmosphere and explain why it's still changing. So having a look at Solo, where do you think you are at now? And can you justify that by writing a sentence? Right, well done. That is lesson 2 completed. So what we've done today is lessons to describe the composition of the Earth's atmosphere. So if you can, just write these down, the main gases from the Earth's atmosphere. Then could you explain why the Earth's atmosphere is still changing? So if you want to write a quick couple of sentences down to explain that. And then finally, could you suggest how we could investigate the amount of oxygen in the atmosphere?